Technical Director at SBI. SBI is part of the working group, the Infrastructure Financial Data Working Group that was formed today. And today I'll show you how we're using XBRL, the open standard for financial data, together with OpenBIM, another open standard, OpenBIM. And this is at a unique, different level because the financial data that we're using, like application for payment, is much more detailed than what you typically find in a BIM-based cost model. And starting with the problem here, so there are 50 states, and what we're seeing is that effectively 50 different ways of formatting the exact same type of document, application for payment. And what we're seeing is that, for instance, Caltrans has its own layout for AFP. Texas DOT has its own layout. Iowa DOT has its own layout, and every other state has, their version or variation of this same type of document. But the underlying data, if you look at the content of the application for payment, is conceptually very similar. Like, you have a payment number, you have a payment date, you have pay amount, retainage information, but there is no shared open standard connecting any of this in the industry right now. So that means every time this data needs to move between systems or between contractors or between a state and a surety company, someone is manually mapping this or writing a code to parse the data from unstructured data to a different type of data system in a different platform. So through this process, what we are seeing is that huge amount of repetitive manual work is going into this. But what if we turn that different data structure into a consistent open format? And what you're seeing here is a proven evidence coming from not the financial sector, but from the building information modeling sector. And so basically, this is showing what happens when you turn different formats of BIM into a consistent open format and the benefits that you can gain. So by using open standard from actual projects, what we're seeing here is, for instance, 92% of time reduction, 75% faster data retrieval time, 33% time reduction, 30% cost reduction reported by different projects using OpenBIM. So the point here is that open structured data actually produces measurable business value, and this has been proven in the industry. So if open standards work this well for physical assets or physical or product models, why not apply the same to financial data? That's the question that we have. And that's our objective basically here. So first, to create a data definition using XBRL to express application for payment in this format. And then second, integrate XBRL with another open standard IFC. By doing this, we have a product finance model, sort of like a BIM-based cost model. And then once those foundations are there, you can move away from PDFs and spreadsheets and help DOTs and stakeholders to communicate better with those open standard formats. So overall, the objective for us here is to show and demonstrate a quick solution for this, preferably using AI, because AI is good at data extraction and mapping. So that's the pipeline that we have planned here. So this is the overall picture of the pilot study. We start with application for payment in PDF format. That is a raw unstructured input on the left side. Then step 2 is use an agentic pipeline that extracts the data from PDF, converts that into JSON format, and then that JSON gets mapped into a structured XBRL format. And then the fourth step there is we kind of mimic that data structure already in XBRL format in the BSDD database. So BSDD stands for Building Smart Data Dictionary. and that's operated by Building Smart. And it's a cloud server of a library or dictionary. So we can push the schema that we have defined using XBRL into a BSD library. Then IFC models should be able to use those properties defined in XBRL, data format because we have that exact mirror in the BSD cloud server. And then the last part is creating a product finance model. So basically integrating application for payment data with 3D objects or IFC objects. And then benefit of this integration is that you can do a financial analysis and risk analysis with actual product model with a detailed finance data coming from application for payment. So this relates to the step 2, where we have agentic pipeline converting application for payment into an XBRL format. And for this pipeline, what we have is at the top you have an orchestration layer, and that orchestrator works with different sub-agents. So we do have a sub-agent that converts the PDF into a JSON format. We are using JSON format because that is better understood by AI than, for instance, XBRL format. And then after the conversion is done, we have to control the quality. So there is an evaluation sub-agent, and if the extracted data is not correct, then it might pass back to the extraction stage or extraction sub-agent. And then if the extraction data or the quality of the data that has been extracted is not ideal, then there is another sub-agent that could potentially update the prompt and improve the prompt so that the extraction could work better. And then at the end of the process, if the extracted data is satisfactory, then there is a sub-agent that converts a JSON into an XBRL format. And this is the target schema for the XBRL. Right now, as we understand it, there is no XBRL schema defined for application for payment. We do have Excel file or a spreadsheet, but there is no structured XBRL definition of application for payment. So for this, you have 3 different constructs, as you see here. On the left side, you have the XSD file that defines the structure of the data, XBRL data. That is sort of like a rule book. And at the center, you have a presentation link base, which defines the hierarchy between the data elements within the XSD. So you might have a parent level, you might have a child level, so that hierarchy is defined here, and then you have a label, a link base, which acts as a translator between machine readable part of the code and translating that into a human readable language. So these are the 3 basic components of the data definition when you are working with XBRL. And this is an example of an XSD file. Right now, we are working with a relatively simple data structure because this is a proof of a concept to start off with. And this XSD file is, like I said, it's a rule book, something you can reference when you are creating an instance of application for payment. The next thing after defining the XBRL definition, the next thing we can explore is integrating financial data with 3D objects, in this case, OpenBIM. So for instance, imagine that you have a bridge deck object, 3D object, and there are application for payments associated with that bridge deck object or that specific work, a construction work. And that linkage can be generalized through OpenBIM standards. So how it can be done is the XBRL can take the data structure that you see on the left side, and the OpenBIM or BSDD can also take the same data structure that you see on the left side. Then the data transfer from XBRL to BSDD should be pretty easy and straightforward. So you can transfer the data to BSDD data dictionary. In a strict sense, you're not transferring the instance or the value, but you're transferring the data schema to BSDD library here. And at the end of the day, when the link is established, an object can have a data structure with certain properties like payment number, payment date, payment amount, and whatnot. The information that you have on the left side, those could be defined as a property within BSDD. This would be a more realistic situation where you have IPC slab linked to work completed in dollar amount, and it also could apply to other types of objects. So you have different types of objects like IPC earthwork, IPC deck, and those objects could have a set of properties related to application for payment, and those properties can be attached through BSDD, which is basically mimicking the data schema of XBRL. So with this workflow, there is a tight linkage between application for payment and individual IPC objects. And once you have that integration, you'd have a financial analysis, something like this. So this is illustrative, but you have IPC object alongside payment information on the chart, and you can actually see how bad or how good the project is performing over time against the baseline in the master schedule. So in this case, the yellow line is the planned schedule, but the actual payment is exceeding the planned payment amount at the end of the project. In closing, I did not mention some of the challenges, but certainly there are some challenges that we need to solve. For example, there could be accuracy issue when we're converting the data using AI. Also, there could be an LOD issue because level of detail of financial data, like application for payment, may not match the level of development of IPC objects. But in any case, we believe that these are issues that can be solved with additional research and funding. So that's the work we're doing, taking something simple as application for payment and integrating that with XBRL and OpenBIM. Thank you.